Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So this video will explain you on vectors in space. Alright, so as you know, vector in space, we will focusing on 3D, 3D, which is you have x-axis, y-axis, and also z-axis. Alright, so you may have three planes here if you see carefully. The 2D planes will be xy plane, xz plane, and also yz plane. Alright, so we also will have a formula in distance. Okay, distance formula between 2 points in space. I think this is from your school, secondary school. You already learned this. Okay, so if you have 2 points, okay, any points here. Okay, so this coordinate can be x1, y1, z1. This coordinate can be x2, y2, z2. Okay, therefore, to find the distance between this point and this point, this is the formula. Distance is square root. So all of this component will minus this component, and then you square it. So x2 minus s1 squared plus y2 minus y1 squared plus z2 minus z1 squared in the square root. Okay, so next page, you may have the examples here. Find the distance between A and B. Alright, so distance formula is square root. All of this component will minus this component, and then you square it. So minus 6 minus minus 1 squared plus 7 minus 0 squared plus 1 minus 2, and then square it. Okay, so the answer is 8.66. So vector in space, you can have component of I, j, k. So it will become ai plus bj plus ck. I in the positive x-axis, j is the positive y-axis, k is the positive z-axis. Right, so next one is position vector. We already learned this in 2 dimensions, so this is now in 3 dimensions. So from A, B, so all of this component of B will minus all component of A. So you have x2 minus x1, comma, and then y2 minus y1, comma, and then z2 minus z1. Or you can write it in terms of I, j, and k. So for example, find the position vector. So for AB, okay, A is your initial point, B is your terminal point. So for AB, all of this component minus this component. So 7 minus 1, 0 minus minus 5, and then minus 1 minus 2. So you have it 6, 5 minus 3. For this one, 0 minus 7, 0 minus 3, minus 2 minus 2. So you have this component. Alright, next one, vector operation. So if you have U and V, where your U is A1, B1, C1, V is A2, B2, C2, and alpha be a scalar, so you can have equality of vectors. So U is equal to V if and only if this is equal to this is equal to B, and C1 is equal to C2. Addition vector, subtraction, you can add both of them, or you can subtract both of them as well. Alright, according to the I, j, and k. Multiplication vector by scalar. So if you want to multiply scalar alpha towards your vector u, you can multiply in I, in j, and also in k. Alright, so next one, length of magnitude. So magnitude of u is just square root a squared, a1 squared plus b1 squared plus c1 squared. Unit vector, again, if you want a unit vector, magnitude is 1 unit, and then the magnitude, this is explaining the magnitude, so magnitude u is equal to 1. So unit vector, if you want to follow a direction of v, therefore your formula is v over magnitude v. Alright, so it is a unit vector that has the same direction as v, and your magnitude is equal to 1. Okay, operation of vectors. For example, this one, 3v minus 2w. Okay, so textbook use the traditional way, 3v, and then multiply 2w. So multiply inside, you can multiply inside. Alright, so 3v minus 2u. You can do like this. Or another way, I think this is the only way. So you need to multiply this, and then minus, multiply this. Okay, so do it carefully, minus here. So I minus with I, the j part minus j part, k part minus the k part. Okay, and then hence find a unit vector in this direction. So you want to find a unit vector towards this direction. So the formula, you just rename this as d. Okay, so the formula will be d over magnitude d. So take the answer for 3v minus 2w, which is this one. Take that answer, and then you divide by magnitude d. So this is magnitude D, 7. So it's D over magnitude D. So all of this divided by 7. So this is your answer. Okay. Next one, operation of vectors. A plus 5B. So this is A. So multiply 5 here. Multiply 5 here. So you just add them, A plus 5B. For 2A minus 4B. For 2A minus 4B. So multiply 2 here. Multiply 4 here. So take 2A, you minus 4B. Next one, magnitude of A. So just square root 2 squared plus 3 squared plus minus 4 squared. Magnitude 3B. Okay, you can do the shortcut way. Take out the scalar here, 3. And then you're just left with magnitude B. So 3 multiply magnitude B. And then your answer is 3, so 13. And lastly, E, a vector with magnitude 30 in the direction of 2A minus 4B. So you want a vector of magnitude 30, but following this direction. So first of all, you need to find the unit vector. So for unit vector, you find a unit vector in this direction, but the magnitude is 1. However, if you want to find magnitude 30, so that unit vector will just multiply with 30. Okay, so find first the unit vector in this direction. We name this as D, magnitude D. Vector D. So 2A minus 4B. So calculate it, 2A minus 4B. So that is D. And then for magnitude D is square root minus 8 squared plus 6 squared is 10. So unit vector in the direction of D is D over magnitude D. So this is your answer. Therefore, a vector with 30 magnitude, you just take 30, multiply your unit vector. So this is your answer.